Front-End Authority is an online community that promotes the ongoing education of front-end technologies.
Hey everybody, I'm Ed. I'm going to be talking about functional JavaScript tonight. I'm an engineer at Intuit. I work on the Turbotax product. I work on the Node.js backend. So I'm a backend engineer. So I know I'm at the front-end authority. So please excuse me. All right. So with Turbotax, has anyone ever used the product? Right on. You guys, how's filing season going for you guys? You guys done? Easy. Right on. So we get a ton of users using the product, and we get it's really important to have accurate tax filings. If we have any bugs that affect tax filing accuracy, it's a lot of bad press for Intuit. It's a lot of lost revenue. So we're really big on testing our code and making sure it's bug free. Which leads me to my topic tonight of functional programming. I'm just going to talk about the Lite version of functional programming. This is basically the 80-20 version of functional programming. So if you're a hardcore functional programmer, I'm sorry, this is going to be pretty basic. But the way I see functional programming is it's using a lot of small functions in your code, trying to reduce a lot of complexity down to small functions. And that really makes your code a lot easier to test. So let me jump into a real example in TurboTax where we're using functional programming. So you might have seen this if you use TurboTax. It's the W-2 entry form. And in this particular version, the form is broken up into multiple pages. So here we have a couple of boxes, a few boxes, boxes 1 through 3 for your W-2. And then on another page, we have a few more boxes, right? So boxes 4 through 8B. This is a totally fictitious example. But the point is that we have like these boxes broken up into different pages. Now, one of the features that we rolled out this year was to kind of reduce the number of errors as the users are entering their information on the form. So we found that using demographic information on all of our users, we kind of know when a box may look wrong. So we have a highlighting feature that tells you if your box may have been fat-fingered. You might have entered an extra 0 or missed a 0 or something like that. So the service that provides the violations is a back-end service, and basically it spits out this JSON array of violations. So you might see like a box 1. I don't know if you guys can see it. I'm sorry if it's small, but you might see like a box 1 is a violation. The value is too large. And then at the top, there's like a UUID, which tells you which W-2 that you have entered. Because users can enter more than one W-2, right? Depending on your filing status. If you're married or single, you might enter a W-2 for your wife, or you might have more than one job, right? So the service is pretty dumb. It doesn't tell you if it doesn't know which page you're on, so it'll return all the box errors. Also, it doesn't know which W-2 that you're on, so it'll return all the errors on all the W-2s. So we want to be able to reduce, basically filter down all of the violations to whatever page the user happens to be on. So we saw that if the user is on page 2, we only want to show box 4, box 5, box 7 violations. That kind of makes sense? Instead of giving them everything. So here's like what we want. Basically, we want a function that takes violations. It takes the page that you're on and also takes the W-2 that you're on. So you got this long UUID. And it outputs it in this format. We do a little massaging, box ID, and then what the message type should be. So the first way to kind of think about this is to consolidate which violations are on which page. So here we start off with a basic page filter lookup table. So page 1 would only has box 1s, box 2, box 3, box 4, etc. That kind of makes sense. And so building on that, so we have the page filters and then the violations. So here's our, let's start off with the function that, that returns all the filtered violations. So this is your typical, CS 101 class, right, where you just start off with a for loop, loop through all the violations, right? And then you look at, which W2 instance am I on? So I'll check which UUID I'm on, right? And that if statement, and then I'll drop down to another if statement to check which violation I'm on, if it happens to be on the page that I'm on, right? So like if I'm on page 2, then I dereference that array that with box 4, box 5, box 6, 7, etc., right? And then I'll check using an index of, I'll check if that violation happens to be in that array. And if it isn't, then, or if it is, then I continue. And then I do an output. I push to an output array. That kind of makes sense? So that's the typical way you'd implement that, right? So it's not too bad. We're just doing one for loop and a couple if statements. So this is basically what's called the imperative programming style, right? So it's familiar. This is what you basically start off when you're doing programming. It's efficient, but it has some problems. When you're adding additional complexity, like when your program manager comes to you and says, "Can you make it do this?" That was basic. So make it do additional stuff. When you add additional complexity to something that's been written in an imperative style, it gets harder to test. It gets harder to reason about because and I'll show an example in a bit. It gets harder to maintain as well. And I'll have an example of this. So let's jump into like what a functional approach would look like. Everybody familiar with lodash? Has everyone kind of used that? No? Okay. Well, lodash is like a JavaScript utility library. But it does have this a method called chain, which takes in a collection or an array. So we're taking in an array of violations. And with a chain, what you can do is you can chain or pipeline a bunch of higher order functions to it. So like filter is something that you can chain on to a chain, right? And filter is a higher order function, so it takes a function and spits out filtered result. So it takes the violations, and then you pass it in a function, right? So v is your each violation instance, and then you're just basically checking if it's the UUID matches. So it's a lot more explicit what you're doing rather than just saying if this, right? You're doing a filter operation. Same thing with the next line. You're doing a filter operation based on the page filters. And then everyone kind of familiar with the map, what it does, it basically does a transformation. So a map takes an element in your array and then does some massaging on it. So that's what we're outputting. And then finally there's a value. Just kick out the result of that chain. So it's a lot more, I guess, explicit what you're doing. It's more declarative than if you're looking at imperative code. So if you're just looking at that function that we wrote just a while back, if you just saw that function for the first time, you have to go and reason what the hell it's doing, right? So if I just saw this function for the first time, I'm looking at it and I say, what's this code doing? It's looping through the violations, and then it's doing something with the UUIDs, all right, and then it's checking on this, all right, if my violation's in in that array of filters, right? Oh, okay, then I'm pushing it out. Oh, what you're doing is like filtering. So it took me all the way till the end of reading that thing to find out what this function's doing. That kind of makes sense, guys? So functional approach is a lot easier to reason about. It's easier to modify and maintain. I'll show an example of that in a minute. But one of the most important things is it's easier to test. It is less efficient. I mean, you're calling more functions, but you know, I think efficiency is like the last thing you should think about when you're writing code, right? So let's look at another example where, like, say your program manager comes to you and says, okay, I want you to modify the behavior of what we were doing. Instead of just filtering on one page, we want to show the user 2 pages of violations. So instead of just passing in page 1, I'm going to pass you an array of page IDs, right? So if you wanted to modify your code in the imperative approach, you'd basically add another for loop to your code. So you'd have to loop over the page IDs now, because that was an array. So that's basically, you're throwing in another for loop in your code, right? But you got to make sure, you know, your indices are good, right? So right here I'm using an index of j in my inner loop, and I got to make sure I don't modify the index on that one, because that's looping over the violations, which is using the I for the iterator, right? So I think it's a lot more mental, you know, mathematics that you got to do. It's a lot more things you got to juggle in your mind when you're reading this function for the first time. Whereas if you're modifying this code in the functional version, you can maintain that same structure that we had where we're filtering on UUIDs, but in the next line, instead of filtering using just that long statement, I'm going to just pass it a function, violation on pages. So that takes the array of the pages ID, and then we're going to loop through that array of pages ID. And we're using this dot sum. There's another lodash utility function. What dot sum does is it returns true if any of the elements in your array that you pass in pass the function that you pass in. So if any of those elements are true for that function that you pass in, then it'll return true. So basically, you're just kind of shifting that complexity down into another function, right? So creating these smaller helper functions like that violation on pages, it makes your code a lot more easier to test, because you can basically, it's, you know, since your function isn't big, right, and you're using these small functions, it's easier to test a smaller function than a larger function, right? That kind of makes sense, guys? And also, if you think about your code, if it's deeply nested, and you're trying to get code coverage on each of the, you know, branches in your function, it's a lot harder to hit this, you know, this special corner case, right? You have to do a lot more. I don't know. You have to basically write a whole lot more tests just to hit that corner case. So that's kind of the approach with functional programming. Is since you're writing smaller functions, you don't have to keep on hitting that deeply nested branch. That kind of makes sense? Cool. Any questions so far? Okay, that's pretty much all I got. All right, so just to summarize, uses .chain method. It's creating like a pipeline of functions. Use higher order functions, or smaller functions like filter, map, and sum. And use lots of small functions, which leads to more testable code. And more testable code leads to less bugs, equals happy users, equals more revenue. Thank you.
It looks like Lodash has a lot of really cool helper and utility functions.
Oh, yeah.
Would you attempt doing a functional approach if you didn't have Lodash?
There's other, you know, like underscores supports Lodash, and there's a newer library called Ramda, which really does functional programming right. I didn't want to use Ramda because it's kind of a, I think it's more hardcore if you're going to do functional programming. So I want to use something that's a little bit more familiar like lodash.
Okay.
Yeah.
What about just straight vanilla JavaScript? Do you think some kind of library is a necessity?
You can do a little bit of functional programming using arrays, right? So arrays have like the filter method, they have reduce, they have and map, right? So you can do a lot of functional like programming with just the plain vanilla JavaScript.
Cool.
Yeah.
So we've recently gone through this on a couple projects in my office, the switch from going from imperative to functional.
Yeah.
So there's kind of two sides of the coin of doing that transition. One is learning the difference between filters and maps and sums, as opposed to everybody knows what an if statement is.
Yeah.
Everybody knows what a for loop is.
Right.
And then, so knowing which one of those methods to write yourself as you're implementing something in functional, and then somebody who's coming into a code base that is using functional programming and understanding what that logic is. Because, I mean, you walk through and you can reason pretty reliably what a bunch of if and for loops does.
Yep.
It may take a while, but you can reason it.
Yeah.
But if you don't know what map does, then
Yeah.
you're probably going to get hung up on that one thing. Do you have any
That's-
advice about?
Yeah, that's something we always kind of battle with my work as well. You know, we have grads coming on board and, you know, they haven't really seen this kind of stuff. What the fuck is a map? And
Yeah.
map, I thought map was a data structure, you know, right? So, it does require some ramp up time. I mean, if you can hold just like lunch and learns with your team and kind of walk them through like what a map is, you know, and I think it pays off big in the end.
Okay, thank you.
Okay.
So, Turbotax super enjoyable, by the way. Last couple of years, no, for reals. There's a lot of little pleasurable interactions, which is nice when you're doing your taxes. I think when I put in my zip code, it was like, "Oh, cool, we're located near you. Hi." I was like, "Oh, that was nice." So, have you guys ever? With something as big as Turbotax, I guess I never opened the console. I guess I was expecting to see that there's some sort of larger framework, like, I don't know, like React or Angular or something like that to kind of help manage the state of all these things. I didn't figure that it was, something like a functional JavaScript kind of building it up. It seemed like more complex.
Right. So like, okay, from like in the back end, there's some functional code here and there in the back end, but like if you're going from page to page, right? It's basically a lot of it's just like you're refreshing right from the server. So we're sending out like a complete dump of new data every time. So there's like no kind of like persistence of data on the front end. Just for like security reasons, we push out all the new data every time the user advances or does something like that. So that's one of the reasons why you might not see a lot of persisted data or stored on the client side.
Anybody else? Cool. Oh, thank you, Ed.
Cool. Thanks, guys.